This is still the test review for Chapter 2 on Math 96. This is the second problem and the last one in the test review. It says, consider the path of a baseball modeled by this function, where x is the horizontal distance in feet, the horizontal distance, and h is the height in feet. So you're throwing a ball basically, or hitting it with a bat or doing something, and it goes up and it comes down, and when it does that, it travels a certain distance. So this graph wasn't here. I generated this graph. It says graph the flight of the ball by finding some ordered pairs. So I went ahead and did that. Now, and I didn't show all my work on this. You can show it on scrap paper. You could use your calculator, but I basically took a whole bunch of numbers from 0 to 350, and I plugged those in for the x in the equation, and I kicked out some y's. And I decided to do it in jumps of 50. I wanted to see what was happening at 0, and I took it all the way out to 350. So these were my ordered pairs, and looks like I probably, if it didn't come out that way, I rounded it to the nearest tenth, but I think that's kind of how it came out. Okay, so and then I plotted them. And even though it doesn't say here, I went ahead and made a trend line on here. So that's what my curve looks like, just like that. All right, so the question on B is, if there's a 30-foot tall fence, 350 feet from home plate, will this be a home run? Well, okay, where's 350 feet from home plate? Because this is the horizontal distance. Well, it's going to be right here. So I found it on my plot. Okay, found it on my plot. Now, it's saying if there's a 30-foot tall fence. Well, if I look at the scale over here, it goes from 0 to 100, and it's in 4 jumps, which means each one of these is 25 feet. So over here is 25, and up a little bit more is 30 feet. So I'm saying, no way is this going to be a home run, because the ball is coming down before. I mean, here's the wall, and at that height, the ball still hasn't reached 350 feet. So I said no. And what I did was I went ahead and took the 350 and put it in the equation. Well, you know what? I already had done that. I already did that when I was finding my ordered pairs. I didn't know that this question was coming, so I got lucky. But basically, that's what you would do, is go ahead and put the 350 in for the x in the equation, and you would find that you'd get 22.5. So my answer is not only no, but because the ball, I don't know what that says. So the ball is too low by 7.5 feet. It's too low by 7.5 feet. Here's 30 feet about right there, and I know that this is 22.5. Okay, so it needs to be like 7.5 feet higher if it's going to make it to the 350 mark, or at least the 30-foot wall at the 350 mark. All right, find the maximum height the ball reaches using the vertex formula. So again, I'm looking for some point up here, and I'm just going to go ahead and take my values from this formula here and plug them in to my vertex formula. So it's the b part is a 1.8, so it's negative b, so I have negative 1.8 over 2 times a, so it's 2 times a negative 0.005. And I ended up with 180. Now, 180 is the x coordinate of the vertex. So I now have to take that and plug it back into the equation where the x's are, and kick out an h. This h guy is going to give me my y coordinate, my y. And the y is the maximum. That's the maximum height. So I don't really need to go any further than that. So the maximum height that the ball is going to reach is the vertex, and it's 167 feet. On D, it says, find the y-intercept and explain its meaning in context. Well, I already did that when I did all of my points over here, and I didn't necessarily do it on purpose. I just was interested from beginning to as far as I could get on the plot. So if it's the y-intercept occurs when x is equal to 0. So I went ahead and put 0 into the equation. I think I even did it again because I forgot I had it up there. Anyway, you end up kicking out the h is equal to 5, or 5. I'm going to put 5 feet on here. But I'm going to explain this. This means that at the time the ball was released, right here, it was already 5 feet off the ground before I ever threw it. And you can see that here because it's above the 0. If it started at the ground, then the x-intercept, the ordered pair, would be 0, 0. But when you plug 0 into the equation, you get 5 feet, which means that that's where the ball started. Okay. And finally, on E, it says calculate the x-intercept and explain its meaning in context. The x-intercept is this guy right over there. They want to know what the heck that is. So at that point, the height is 0. Y is equal to 0. So I went ahead and put 0 is equal to the equation. And I don't have to do any shifting around because I already have a 0 there. But I am going to use the quadratic formula, which I have written out here. X is equal to negative 1.8 plus and minus square root b squared, which is 1.8 squared, minus 4 times a, which is negative 0.005 times 5, all over 2a, which is 2 times negative 0.005. And you're going to have your calculator do this. And again, you can do it a whole bunch of different ways. And then I ended up with 2 answers, one coming from the plus, one coming from the minus. This guy I'm going to drop out. He's going to drop out. There's no way that the x value is going to be a negative. There's no way. And if you think about it, this is my distance. This is my horizontal distance. And I'm not going to have a negative value. So that means that only this guy makes sense. This 362.76. And again, this is feet. So I'm going to say that at this point right here, that x-intercept, this is where the ball hit the ground. It's approximately 362.76 feet from where it began. And that's the end of Chapter 2 test review.